Today I want to share a story with you about Navigation 3 and its adoption in a production app. We'll go through our approach with migrating to Navigation 3 from Navigation 2, our hesitance and question whether we should do it. Is it the right time to do it, or should we wait, which I would assume a lot of people have a question nowadays. Our learnings from it, and we will close with some recommendations for whoever is actually thinking of doing such a migration. Before I move on, can I ask the audience how many people have been using native Navigation 3 in production or are thinking of using it? A few hands, nice. Would expect less hands, to be honest. So, a few months ago, when we started designing the React Native to Android Native migration, we started with Navigation Compose Nav2 as our foundation for the navigation of the application. But then Nav3 landed, we thought of it, and we decided to actually adopt it in our app and use it in production. The question is, was it really worth it? Before I continue, let me present myself. I'm Efthymios Kontis, or Makis, as most people know me. I'm a senior mobile engineer here at Zopa with more than 10 years of experience with mobile development. As I said, I'm part of the team that is leading the React Native to native migration. I'm a Android regular. It's nice to see a few familiar places, so thank you for joining us. So, let me set a bit the scene here. We're not talking about a side project here where we can experiment as much as we want with navigation. That's a real banking app, a real complex navigation. So we have our opinions and choices will affect the way our team our team builds features. Just to give you some insights about the team here at Zopa, we have around 20 Android engineers. They are split between multiple product teams. We have a big code base of around 70 Gradle modules, and it's growing fast. And we have around 120 screens, which as well are growing fast, that we have to navigate to. So you can imagine at that scale, and we have a lot of different products, loans, credit cards, investments, savings, and all of them have cross-selling communication, so you have to go from one to the other. So you can imagine that at this scale, any navigation decision we make affects a lot. Before I go to Nav3, I want to be fair with Navigation 2, because I would assume a lot of you in the room are still using it in production. So Navigation 2 is, at the moment, still referenced in the Android docs as a stable approach. It has a lot of benefits at the moment, so it's a framework that most of you are using in production at the moment. It's been battle tested in production at scale. Most of us are familiar with it. It has an active community, writing documentation, sharing knowledge, a lot of strong examples of how to do things. Very important, it works with fragments and legacy apps. Not everyone is using Compose in their whole app. So the fact that is very important. And it covers most of the scenarios that you want from your navigation, like deep links, nest graphs, multiple backstacks. But there are real friction points, especially when it comes to Compose first applications and development. We all agree that Nav controller, it hides a lot of the state in the framework object, so it feels like a black box sometimes. You don't know what's happening unless you've actually gone inside and seen it. We have a backstack that manipulating it is updating, changing it. It becomes quite hard behind that framework. So as the complexity of your app's navigation grows, you end up having more hacks to do in your navigation. Adaptive layouts, we've seen that there are many foldable devices coming out. We've seen that a lot of people and manufacturers are heading towards that direction. So that's something really hard to handle at the moment. You have to change how you create and structure your screens. That doesn't come out of the box for you. And if we're all honest, it does feel like an adopted abstraction to compose. But navigation 2 is not going anywhere. Again, a lot of production apps are using it, so it's not a switch that will happen in a few months. So it will definitely stick around for a while. Now, Nav3 flips that model. The one thing that we always need to have in mind when we talk about Navigation 3 is that navigation is just a state now. That is the biggest differentiation of Navigation 3. It's composed first and state-driven, and it's not just a framework anymore. You own the backstack. The backstack is now a list. You can push screens, you can pop screens, you can shuffle it, you can do whatever you want. Some of the benefits, as I mentioned, is that this is designed composed first. The app owns, so you own the backstack and your navigation state. You can push screens, you can remove screens from this list. It feels like a natural fit when it comes to unidirectional flow and state-driven UI. And it comes out of the box with adaptive layouts, which can show multiple destinations very easily for foldable devices. But that sounds like a very powerful framework, right? With more power, though, comes more responsibility. It's a completely new mental model. So navigation as a state, again, this needs to sit with us, because that's the biggest change of this navigation library. It's not just commands to your navigation controller. APIs are still evolving, so this library only became stable back in November last year, so there are a lot of things coming out, improvements, and as we see, it's less historical. The production usage is not even close to where Navigation 2 is. Another big thing for this is that migration now for Navigation 3 is not just a dependency swap, but it's an architectural change in how we actually build our apps. And that's a very important thing to have in mind if you decide to migrate, and we will talk about that in a later slide. So, how did we actually wire this up in our application? I will go through some of the use cases that we implemented and are some of the use cases that everyone is facing in day-to-day navigation in their apps. Let me give you a high-level understanding of the navigation architecture that we follow here at Zopa. So this is a one-way data flow. You will see that we have our screens, which is simple composables with their view models. What we don't want is the screen to be polluted by the navigation noise, the navigation business noise. What the screen does is just emits an intent, an action that is being picked by the coordinator. The coordinator encapsulates the whole navigation business logic and is in charge of deciding where to go next. I'll give you a very simple example of how this is very handy. We all have to deal with A/B test experiments. If that A/B experiment is to navigate to two different screens based on A or B, this is where that logic will sit. And it also makes our navigation business logic very testable without being affected by anything related to the framework. The coordinator has access to the navigator, which its own single responsibility is to own the backstack. So it manipulates the backstack based on the coordinator decision. That backstack, because we now own it, is observed by the nav display, which eventually renders our screens based on the scenes. You probably know about the scenes. Just a quick reference is a way for the navigation tree framework to determine whether it needs to show one or more entries in your screen based on certain conditions. One key takeaway here is that we had the coordinator pattern, so that model existed already, so it kind of felt as a natural fit for navigation tree to come in here, and it made it a more cleaner state-based foundation. First use case that I'm going to be talking about is the nested flows and the shared view models. It's something that we all need. That's something that is very straightforward with Navigation 2. In Navigation 2, we have the nested graphs by default. It's part of the official API. And we can use that nested graph as a view model store owner. So we can scope our view model to that and share it to the destinations of that nested graph. If we take this example of a checkout nested graph, you will see that we have the app nav host. We have the home screen there, which redirects us to a nested nav graph, a checkout graph, which consists of 3 screens: the address, the payments, and the review. The checkout view model here is scoped to the checkout graph, so as long as that is in our backstack, our screens can use it. How we do that now in Navigation 3? At Zopa, we have 2 options here. The first one, which is the one that we're mainly using and is not part of the official recipes repository. Let me show the diagram here. So this is dependent on self-contained flows where we can use the root float key as the owner of the view model. So we have a root nav display. We have our backstack, which at the moment consists of just home key and checkout flow key. For the checkout flow key, we have the checkout flow screen composable rendering in your screen. Now, we define the checkout view model in this composable, and we have an inner nav display acting as a nested graph here with the screens that we want. That checkout view model now can be shared in these entries and is scoped to the checkout flow screen. But there is a catch. Let's see the code. As I said, we have the nav display. We need here to make use of the decorators. And this is something that we learned the hard way, finding and searching for a bug. So it's very important to not forget to include this decorator in your nav display. What the Remember View Model Store nav entry decorator, I don't know who came up with this name. But what that decorator does is that it gives our entry its own view model store owner. If we didn't have that, our view model will be searching for its closest view model owners. And the closest one here would have been the activity. So the view model will eventually have been scoped to the activity, and that's definitely not the behavior we want. Another very important tip, I'd say, because that's another thing that we found the hard way, is that the order of this list matters. If we reverse this and run this decorator first, then we will not get the desired outcome, because the Remember View Model Store Nav Entry decorator internally uses the savable store, which comes from the first decorator. So if this is not called, then we have an issue. The checkout flow screen here, you can see how we define the view model over there. That is scoped to the nearest entry, which is the checkout flow key. So as long as this entry, is in our backstack, we can use the view model in the screens of the nested nav display. That's the first and default way of having nested flows and shared view models at Zopa. There is a second option, though, which is more advanced and comes with more boilerplate code. The shared view model via decorator. This is the example that you will find in the official recipes repository. What this tells us is that we can use a parent owner and share its view model across the sibling entries. So we have a parent entry which has the checkout view model scope to it, and the sibling entries in a flat nav list can access that by defining something in the metadata of the entry. Let's see the code. The keys, just defining the keys as serializables. And you will see here that we need to add the shared decorator. Now, the remember shared view model store nav entry decorator. It's important to note here that this is not part of the official API. This is part of the recipes. And it's required. What eventually it does under the hood is gives to sibling entries, swaps their view model owner store to the parent that they have defined in the metadata. So we define here the checkout parent key, and we need to have a stable key so that the children can reference. We have the view model scoped to that key, and then our sibling entries can access it through the metadata defined at the entry level. Great. So next use case, deep linking. Everyone needs deep links in the app. It's one of the most important features that navigation requires. This was me when I was looking through the documentation, probably a few of you as well. Yes, there is not an official deep linking API yet as part of Navigation 3. That was a bit weird initially, but let's take a step back and think about it a bit. They're giving us ownership of the whole backstack. So shouldn't we have ownership of how we handle deep linking? Again, a comparison with Navigation 2. This was very convenient in Navigation 2 because the deep links you could declare that close to the destination. Your framework will handle the URL parsing, the argument extraction. It will take you to your destination. That came out of the box as part of the official API. But obviously in production, it could have become more tricky because we have many different use cases depending on how complicated your navigation is. If we take the example of this deep link, we will have to check whether the user is logged in, whether that product is active, what's the back behavior. Different products might require different backstack behavior. So because the backstack here is, as we said earlier, inside a closed black box, it's very hard for us to actually change it. So Navigation 3 forces you to be much more explicit about deep linking. Yes, it does mean that you will have to write more code, but that means that you will decide exactly how your deep linking logic will behave. How it will look like in production is we receive a URL, we have to validate it, match it, parse the target, match it to the nav key, build our custom nav stack if we have to, and then render it through the navigation display. So as I said earlier, Navigation 3 did not make deep linking easier, but it made them more clear. When you're dealing with a complicated navigation, the ability of creating a centralized place that handles your deep links the way you want to be handled, I think it's definitely worth the boilerplate code. Obviously, I would expect few of these things, and hopefully that will happen in upcoming releases of Navigation 3, that some of these things will come out of the box with the official API. But owning the logic of it, I think it's a good thing. Another very common pattern that we face in navigation is back navigation with a result. Imagine the scenario where you have a payment screen, you tap on to select an account, so a new screen shows in your app a list of accounts where you have to select from. The selected account returns back the ID of that account, and that updates your parent screen. This is a very common pattern in navigation too. You would use the previous backstack entry, you will pass that account ID, you will pop back to your nav controller, and then your parent screen will just access it through the save state handle. It is convenient, but it's definitely tied to the backstack internals. So how Navigation 3 works with that? If you've seen the recipe repository, you will see that we have three options here. They recommend the result store and the result event bus. The result event bus emits it's using a channel to emit the data, but while the result store can store it until we access it, and then it's up to us to decide whether we're going to keep it or clean that store. The way we're approaching this in Zopa is that we have this type result contract that you see. So you see the sealed interface. It's a nav result contract with a key. Every result requires to implement that contract. We have a namespace key there. The child screen is adding the account ID or the result in this store and goes back, and then the parent screen just observes this result store and uses the data and passes it to view model or any other transaction that needs to happen. One more thing that I feel is worth calling out is the animations. Animations explain to our users the way our apps should behave, the way we handle the different screen transitions, make our screen feel more elegant, our app more elegant. This time, Navigation 3 includes animations. This is part of the official API. We have forward navigation, back navigation, and predictive back navigation out of the box. We don't need to add any other libraries. The system just drives the predictive back. So, going back to the initial question, was it worth it? This is not a yes or no answer. I think it depends. What I would recommend is having a very simple decision matrix that you can use. On one side, if you're compose first and you're starting today a new app, yes, go for Navigation 3. This is where Android is heading to. You'll get navigation as a state, type-safe routes. It fits better for adaptive screens, multi-pan layouts. It's aligned in general where Android is going at the moment. But what happens if you already have a very complex, big app, complex navigation? Unless the return of investments here is very clear, I would not recommend using it. One of the main reasons that we said at the beginning is that migration is an architectural change and not just a dependency swap. So even the name Nav3, it feels that this is an incremental upgrade, but in my opinion, it is not. It changes the way you're handling your navigation completely in the app. Another very strange thing I noticed was the official guide assumes one atomic migration. Who has such a simple navigation to just do one big atomic migration? I mean, imagine the size of the APR, right? They're assuming that we have testing coverage, but that doesn't solve a lot of issues that might come out of a big migration. Another thing about the atomic migration, I would again be against it. And if anyone is thinking of migrating, just start small. Even if that means breaking your big navigation, your single activity architecture, just open a new activity. Test the small, low-risk flow, how the navigation tree behaves. Is your team ready to adopt that new mental state? And obviously, if you have fragments still in your app, this is definitely not something that you should consider before migrating to fully compose. Another big takeaway, Navigation 3 is the better direction for new compose first app. But as we said earlier, Navigation 2 is not going to go anywhere. It's still the safe choice for existing production apps. And just because there is a new fancy Navigation 3 doesn't mean we need to migrate to it. With Navigation 3, it was, I think, the first time I saw in the official docs a ready-to-copy-paste AI prompt to migrate your app. That sounded a bit strange because it comes back to the migration is an architecture, not dependency swap. How does the AI will know exactly my architectural shift before my team? But speaking of AI, you will see that recently the new Android Skills official guidance for AI agents was released. They have a specific Nav3 skill, which I definitely recommend people going through the MD file and just reading it. You don't have to use it, but it has some very nice and good tips on how to use Navigation 3, and also the Android CLI, which makes docs, builds, tests, and iteration much more easy for agents. And as Neil said, we are still hiring at Zopa. If you're interested, feel free to scan with your phone. If your colleagues or manager is next to you, you'll find that QR code in many other places. Just saying, leaving it for a bit more. Thank you very much. This is now your turn.